Now, I'd like to introduce our next speaker. I'm very happy to have Paul Kruszewski, and he's the president of a company called WRNCH. Paul has got entrepreneurialism in his blood. One of my favorite quotes was when he was 12, he parlayed a livestock deal for $250 into a new TRS-80 computer for himself. Then he founded a company called AI Implant, which developed the world's first real-time navigation middleware for 3D humans. So Paul's coming to us from a gaming background and is going to share how he sees the democratization of computer vision development through what's happened in the gaming industry and drawing some parallels from that. And so I'd like to take a moment to thank Paul for presenting and hand it over to him. Great.
Thanks so much.
Thank you so much.
Good afternoon, everybody. Is this my clicker, I guess? Okay. So, yes, thanks a lot. I want to give a very sort of different perspective, but I think the more I do computer vision, the more I think it's actually potentially interesting for everyone here today. Just like that. Oh, there we go. Yeah, so, what are the bottlenecks to democratization? We're going to talk about that. I think this morning, I think we spoke a lot, you saw a lot of things about what's not stopping the adoption of computer vision, but let's talk about what is. I want to talk about an industry that I know very well, is the video game industry, because I think how we solve these problems, similar problems in the game industry, I think are useful for people to think about. Not only the people who are building technology companies, but people who want to deploy computer vision technology. I want to give a little sense of where we're at in 2016, and I personally think this is a great opportunity for all of us to calibrate and get a sense of where the industry's at. And just give you a sense of how I think this could roll out, given what's rolled out in 20 years of computer games. So yes, I am just a little bit about myself. It's a true story, actually. When I was 12, so I was born in '67, and so in 1979, I wanted a TRS-80. It was $1,000 in 1979. That's a lot of money now, but it was a lot of money. And so I grew up on a farm in Alberta. I raised pigs. I didn't get an allowance. I raised pigs. So I sold the pigs for $250, but that's not $1,000, right? So my brother, who is younger, he also sold pigs, and he had $250. So I said, hey, Todd, give me the $250. You want to play video games. We're going to get a computer. And so he said, yeah, sure, I'm in. And so then now I got 500, but I still need 1,000, right? So I said, okay, Dad, I put in 250, Todd put in 250, match us, programming's the future, I'm gonna learn how to program. And my father, he put in $500 and there you go, we got $1,000 and we get a computer. And yeah, the first thing, of course, I wrote was a video game. But that's sort of been my modus operandi ever since. And I founded and built and sold two companies in the game technology space. WRNCH is my latest company. We started 2 years ago in a tech incubator, officially spun out last year. We're 10 people in Montreal, Canada. Post-revenue, which is a beautiful thing, a new one for me in the startup scene. And Mark Cuban is our lead investor, so I'm very curious about the Vision Tank this afternoon because no, I did not go on Shark Tank, but yes, Mark is just as intense in person as he seems on TV. And I think where WRNCH is tackling this is we're really a bunch of, to be honest, an interesting mix of computer game people and computer vision people. And what we want to do is, take all the innovation that's in computer vision and bring that to digital entertainment. And that's really where we're coming at this from. So, I wish I could have updated these slides in real time and actually stole some of the slides from this morning because they were so great. I mean, you see it. I mean, sensors are insanely mature. The processors, it's incredible. I mean, we could get into that debate of whether it's going to be in the cloud or on the edge or not, but it'll be both. But clearly, compute is not a problem in a lot of ways. And even, But what is the problem? Why isn't there, like, order of magnitude more computer vision applications across everything, right? And, oh, there we go. And the fact of the matter is, it's still really, really hard. I mean, there's just no, cutting it any other way. It's a field that's been maturing 30 years, but we have a long way to go. I mean, this is the state of the art, quite frankly. What do? You want to do a computer vision application? Hire a bunch of PhDs in computer vision. Get OpenCV and start hacking it. How many? Just out of curiosity, how many people have been on a team like this? All right. So what are the advantages of this approach? Those are two of my PhDs hacking away on OpenCV right there at the office. It's software, so we got complete flexibility. You can do anything you want, right? I mean, that's the beauty of software. You have complete control. You can build this fine-tuned application. But what's the problem, right? I mean, and they were talking about this in terms of deep learning. There's a chronic worldwide shortage of all PhDs in computer vision, especially in computer science. And frankly, the reason the vast majority of people go do a doctorate is because they want to do research, not that they want to do particular engineering. And so, so there are not many people who can do this. They don't necessarily want to build your application, so that's problem number 2. And OpenCV's made a lot of strides, but I think the consensus is OpenCV is very powerful for building, prototyping, but deployment is still an issue, And then there's just the generals of normal software development, like Peter outlined this morning, was software development. It's risky, time-consuming, it's expensive, and I think Peter brought up an excellent point this morning about the cost to maintain, because it's one thing to get these things out the door, but then once you want to maintain them, once your compute platform, the iPhone 7 comes out, what do? So on and so forth. And frankly, for a lot of companies, computer vision is a means to an end. It's not, it's not their raison d'etre. So it's going to be hard to attract a team to want to do that. So this is not the first time this has ever been solved. I mean, this has been solved by many, many industries in computer science. I think the one that has the greatest analogy to this and where to learn is a buddy of mine at ARM, when I was first moving from computer graphics into computer vision, gave me a really great way to look at the problem of, computer vision is, in a certain sense, it's the ultimate data compression industry, right? Where you take all the visual complexity of this world and you just grind away and you get very simple data and rules, right? Like we could take all of this and say, it's X hundred people listening to this one guy talk. And what I find interesting is I think this is the dual. If I look at the whole field of visual computing, this is the dual, if you will, of what computer graphics is, right? Is computer graphics, you have a scene file, you have a few rules, you have L systems, whatever you want. Grind the compute crank, and you get all this beautiful visual complexity, if you will. So what I want to do in the next 5 minutes is just give you a little sense of how computer graphics has evolved from, proprietary development to complete commercial ecosystems, and then give a sense of where this can evolve in computer vision. So I mean, this is where we were when some of the first, you can call this one of the first video games. There's a lot of controversy, which is the exact first video game. I'm not here to get into that, but that's Space War on a PDP-1, so I think that's pretty beautiful, and they had 3 programmers on that. So they already had a team. That was in the 60s. But, for games now, there are thousands of people on this. Like, I come from Montreal, which has a huge gaming hub, about 10,000 people. Ubisoft builds Assassin's Creed, things like this. They literally have 1,000+ teams. They're building in 3 cities at once, so they can have basically 24-hour development going on. Incredibly complex, right? And then you just look at the visual quality. Well, that's on an oscilloscope, and that's on a 4K TV. And how did we get there? Because I think that's where when I see if I see a summit like this, and interestingly enough, there's this thing called, so the analog of this would be Game Developer Conference. Has anyone ever gone to Game Developer Conference? Because I'm just curious how much overlap there is, because I know there's a lot of us. So there's a bunch of I call it the game refugees who are going into computer vision, like myself, and like a lot of interesting people. That thing has got 15,000 people, right? But I started I think it started in '96. I went to my first GDC in 2000. It was in San Jose. Not much bigger than this. And now it's 15,000 people in San Francisco. So I feel that we're at the beginning of something very interesting. And I want to talk about how we did it, and we collectively in the game industry solved this. Because it really feels like the early days here. So just, again, for the people who are gamers, you've lived this, you grew up like this, but if you're not gamers, it'll just give you a sense of, I think what's interesting for all visual computing is that hardware drives everything. If the compute's there, smart computer scientists will figure out ways to exploit it. We were at the lunch table. There was a bunch of us at a table, and there was some Intel guys and software guys, and we were having that exact conversation of like, provide us the compute, we'll want to exploit it. And so you can just see like the first wave of how did you go from like just some people programming on a PDP-1, so that's like the PlayStation 1. I'm going to use Lara Croft because what's interesting about Lara Croft is she's well known and she's evolved with the thing. So she just gets more and more, well, I don't know if I wouldn't say realistic, but higher fidelity, if nothing else. So the first real wave was tools, okay? In the sense of these are not SDKs, these are not runtime engines, they're just tools like Maya, Max, Photoshop, and they allowed all of a sudden non-programmers to contribute to game development. And by that I mean actually create art. So this was really the end of programmer art. Then sort of like the next wave of this was really the low-level APIs in the sense of this allowed people no longer, they had to write to the metal, if you will. You could start writing OpenCL, so on and so forth. I'll talk about how this relates to where we're at in just a minute. But you can see at each time, you can allow, the teams can get bigger, not because you're hiring more programmers, but now you can get different kinds of people working. And I think that's what this industry needs to do. So we go to the PlayStation 2, Xbox One, or Xbox 0, I should say. So now you're going to start to see the evolution of middlewares. So what's a middleware? It's a specialized component. It's either things that's going to render the graphics, render the animation, render the physics, render the AI, so on and so forth. The idea is that programmers now could work on a higher level. You could start to assemble, if you were building a game, you could start to assemble modules, and you could glue together. Aha, well, I'm going to choose this physics engine from this company, this low-level AI engine from this company, this high-level AI from this company, so on and so forth, and you glue them together into this thing called a game engine, which we would call, in the space, an application. And the interesting thing, too, is because you're starting to abstract it out, you can have more multi-platform development going on so that you could, from a business perspective user, you want to publish your game on as many platforms as possible because you want to get as many users as possible, right? So now you could author once and publish to the PlayStation 2 and the Xbox. Then the next sort of wave, and this is where I think we're at right today in computer vision, is this notion of frameworks where people are starting to glue together into more or less an engine. It's still not an engine, but it's almost there in the sense that you take this bunch of source code, you refine it into your engine, and then you start to add content. And again, this says, now I'm going to say, I could take my framework, I want to build a shooter. I want to build an RTS, so on and so forth. And again, this allowed to expand the market quite a lot. So really where we're at today is PlayStation 3 and 4 moving towards engines. So this is where it got really interesting, and I'm waiting for this to happen in the computer vision. What's an engine? It's everything you need to build a game. You literally, all you do is you throw content at this. Now, content means art, gameplay, so on and so forth. But everything else has been solved. Still an insanely hard thing to do, but now it again allows different people to participate, and allows the games to get a lot more bigger and more complex and richer experiences. And I think for those of you who've been in the game, who've played games, and you think about it, just think about how much more complex those games are getting. And getting back to, I think it was the Qualcomm speaker this morning saying about how we're really just scratching the surface of what we can do in computer vision, and not get stuck. We're saying, okay, all we can do is facial recognition. All we can do is object recognition. What are the higher level things that we can do quite soon? And but from a business perspective, also now it's a double-edged sword, right? Because now anybody can go buy a game engine and assemble a team. How do you differentiate yourself? You don't get to differentiate yourself on the computer graphics. You have to differentiate yourself on gameplay, story, characters. And I think that's where we will see at a certain point in this industry, there'll be companies exploiting computer vision, and they may be solving the same problem in the same industry, but they will differentiate weirdly not on the tech, but on some specific kind of hook. They might actually be licensing the tech from the same company. And this notion again of author once, publish everywhere, right? Going to this idea of what was really great about these engines is, especially Unity really mastered this. You could author your system once, and you could publish on basically anything with a GPU. So every phone, every game platform. So then sort of the next step, and this is where we're at right today, is this whole notion of ecosystem. So this goes much beyond that. Not only now can you just get a game engine, but you can buy assets. So you can buy characters, you can buy weapons, you can find contractors. So there's this whole notion of that it's an online marketplace. There's a lot more analytics. I think where it could evolve in a very interesting way here, and building on, I believe, the first speaker's talk, and the second was this notion of perhaps data sets. Perhaps the ecosystem that's going to evolve in computer vision will not even be so much technology, but maybe it'll be open source, but maybe it'll be a company that owns this large data set, and people will go and say, I want to license out your data set to train such and such application. And that's really where we're at. And today, when I got in the game industry in '99 as a CTO of a 100-person company, and it was still very black art. Nowadays, you literally 5 people can download some tools and build a great game. That's where I'm hoping us collectively as an industry can get in computer vision. So this is just sort of interesting to watch the M&A perspective on all of this. So the sort of phase 1 here is our software vendors. So you can see where the tools got all absorbed by Autodesk. My first company got second company got absorbed by Autodesk. First company got absorbed by the military. Then the game publishers absorbed a lot of technology. So weirdly, this game tech was to allow new independents to build games. But what ended up happening was a lot of the large game publishers said, that's great, we want to be efficient, only us. So they ended up buying up a lot of technology. And then the platform manufacturers also ended up buying a lot of this tech. So you could look at all through these companies. And then this is where it gets really sort of fun. I thought about these two. So 2 things in game technology that people don't really think about are the following: is Google Earth, actually. So Intrinsic Alchemy, they did a spin out, which was Keyhole, which was Google Earth. So when you're using Google Earth, you're really using game tech. And so I think that's the same thing where we're going to see here is computer vision technology will start in one way, but it'll fork in a direction and people won't even know it was computer vision technology. But I think it's interesting is the Oculus, ultimately the core founding team of Oculus all came from the video game space. They're the ones who built this thing called Scaleform, which was a UI engine for games. It got bought by Autodesk we used to travel a lot on shows, and they jumped over into Oculus and founded that company. So what have I learned over almost 20 years in computer game technology? Is hardware opens up all the opportunities. Every time a new console was introduced, new companies could emerge. And so I think that's where it's interesting, where new GPUs, where new mobile chipsets are introduced. That's an opportunity to start companies. But every time there's an era, if you will, new people can join, and that I think is very interesting. So, and I think we're seeing that even in computer vision, right? Of originally it's all just, algorithmic engineers. Now there's learning people. Now there's data scientists. And so as we evolve as an industry, we're going to not only have more of the same kind of people, but a lot wider group of people, and more specialized roles. And so what I saw was, again, tools and low-level APIs are going to come out first. Then middleware sort of give a specialized piece of functionality. Then people start to glue those things together into engines. But the winning engines really form the ecosystems, because in all technology, it's a winner-take-all. Ultimately, you don't want the third best computer vision solution. You want the best. And since it's software, everyone on a certain level can buy it. So where are we at right now in terms of computer vision? I think we're at the early days of still contractors, tools, and middleware. I think that's where we're at. I don't think we're at an engine thing right now. And how do you choose? So let's say I think Peter's talk was very helpful. Of you want to build this application, and let's say you don't have the team. There's the obvious of, like, you want computer vision expertise, in a team. Like, how do you judge a contractor? How do you judge? You want to outsource your computer vision. You want to build it. I think the less obvious is that you really do still want to have very domain specific. Like, if your application is military, for example, we are bad. We're bad for that, from two reasons. We don't have experience in that, and we don't have interest. And I think if somebody says, "Oh, no, we'll do that for you," I would really step back and say, "I'm not sure why, that." I think the more important thing is cultural fit. If you're looking to work with somebody, find out what kind of tools they want, because if they're not already using the same kind of tools and the same kind of methodology as you, they'll probably say that they will. Of course we will, because we want to get your deal. But that's just going to be painful. So and it's really, you may not think about it. You may just say, "Oh, I just need a computer vision team. That's all I care about." No, if you do source control in one way and they do it in a fundamentally different way, but you need to have that. It's a hard conversation, and don't take that. Same thing for tools and everything else. And then the very important question of who owns what part of the IP. Have that conversation very early. In terms of actually licensing code, I mean, these are the obvious things of cost, functionality, and performance. Those are the ones you should think. But think of all the other things beyond that, right? Of ease of development, because it could be something very cheap, but how easy is it to use? And I think, and again, I think open source has a great place, but I don't think anybody would say, ease of development is a big thing for open source. And then ease of deployment's even more important, because so you get this thing working, and you've solved the robustness issue, which I think was an excellent point brought up this morning. But what's the ease of deployment? How easy is it to actually get it to deploy to an iPhone 6, an iPhone 6S, Because this can be a huge stumbling block. And is it future-proof? Will this automatically, work on the next generation? So this is what we've seen so far, and it's a relatively new space. So in the first in computer games, it was really the software vendors who was sort of the most active of buying up people. But really, it's the platform people that are really consolidating even such an early industry, right? Of Oculus, buying Surreal, the AR toolkit for Daiquiri, Meta IO in Apple. We see this a lot already of, I don't know if you guys know this one of Snapchat, but basically so that whenever your teenage daughter takes photos of you with flames coming out of your ears, there was a computer vision company in Europe that basically could do face and eye recognition. And the software vendors are there. I mean, probably the biggest kit in AR is now been transferred to a software vendor. So just sort of to conclude, I think this is where we're at, right, of APIs, still very much in the tools. I don't think the frameworks are coming out just yet. But I think as time goes by, I think in 2 or 3 years from now, you will see entire ecosystems built around 1 or 2 vendors that everything plugs into. So that is my talk. Thank you very much, and I'm happy to answer any questions.
Thank you very much, Paul. It was great to get your perspective on what we've seen already in the gaming industry and how that impact potentially could parallel what's going on in computer vision. So there's some mics on either row there if anyone's interested in providing a question. But I've got a question around, so one of the other aspects of it is what are some of the parallel business challenges that you've seen in the creation of the middleware, the frameworks, the engines that might be paralleled in the computer vision space?
Excellent question. I would say the biggest one is the classic, whenever you're selling code to coders, as I always like to say. So you're selling to teams that have, typically you're selling to teams that have computer vision teams, potentially. And again, so in the game industry, early companies would say, you don't need to, you have a game and you have a game programming team, we'll sell you the physics module and you don't need to do that coding yourself. That's a hard thing because you can't be just as good, you can't be 10% better, you have to be an order of magnitude better. And I think that's the same thing here, and especially so I know personally how we're approaching that is, I mean, you can do that and companies are successful, but it's very, very hard. You have to have something super game changing. I think where the opportunities were in the game space, what we did in the game space, and what we're going to do in this space is say, all right, that's great. There are these sort of super developers with all these great people. What about the people who are right beside, and they want to go in that space? How do we help them? Mm-hmm. So that's what we're doing right now with this very large U.S. Entertainment brand. They want to build a certain augmented reality system, and they've come to us to build that out. So I think that's really for all the tool vendors, all the contractors, think outside of this group, bring more people here.
Got it. Okay. So we have a question over in the side there.
One of the issues that I've seen a lot is the hardware side. Since you have the capture devices as an integral part of a lot of these solutions, there are literally hundreds of vendors, and this space is moving very quickly too, especially if you get into 3D sensors. You want something that's inexpensive but good quality, and you have all these different trade-offs. How can you have a single software framework that all of these things are going to fit into? Because these do impact all of the algorithms and all of the code that gets developed to do whatever you need done.
You're 100% right. And so I think, well, my easy answer, but I truly believe it, is that it's just too early for it to happen yet. In the sense of, just like we saw, in the mid-90s with all kinds of different graphics cards. I mean, developing on a PC in the mid-90s, if you were doing any kind of 3D graphics, it was hell, right? I mean, you literally, that's why everyone wanted, because you had to test on every card and every configuration. And that's why everyone loved the consoles, because that was this closed platform that basically you said, if it worked on one PlayStation, it was going to work on the 20 million PlayStations. So to answer your thing, I think it's going to be an interesting dog's breakfast of, you're going to have certain people will choose to work on I would call closed platforms like an iPhone or something. Because even Android development is brutal, right? Getting it to deploy against lots of different phones. So I think it's a matter of time more than anything. But I know it's happened, and I think it'll happen, but the hardware is going too fast, right? So I think it's maybe X year, a certain amount of years before a general framework can work.
Great, thank you. Well, I think you've added some interesting insights that bridge some content between one industry to the next, and I appreciate the questions from the audience. And I want to thank you for a fantastic presentation.
Thank you.
Paul.
Appreciate it.
Yeah.